when you hear the word double OP, should ring your bell. What is the double OP stands for?
Object-oriented programming.
Yes, exactly, object-oriented programming. Therefore, right now we have structured programs and object-oriented programming, right? And right now, then here Java is an object-oriented programming language which create objects which contains both data and the methods, or you can say fields and the methods, right? Then what is a structured programming or what is a procedural programming, right? If you talk about what is a procedural programming, right? Now, in those programming languages, they relies on how by writing procedures or writing methods which perform on the data. Then, what's the main difference between object-oriented programming languages, or what are the advantages? Then you can say, then here it's like real world. Objects communicate with each other, therefore it's faster and easier to execute. And then right now, because of these objects, right now without we will be able to reduce the code repetition. Therefore, because we can reuse the codes, therefore it will allow us to structure the program as the way to maintain the code clean and in order to reuse the codes. Right now, mainly, what is a Java? Then you can say Java is classes and objects. We already discussed what is a class. Class is we discussed class is a template or class is a blueprint, and objects are created based on the classes. Then object is an instance of a class. That's what we discussed. Then objects are created based on the classes, and each object has or each object inherits the methods and the variables available in the class. Therefore, in the class, at the time you declare a class, you can declare the variables and the methods in the class for objects to inherit those. Right. Then, if you talk about class and objects, then you can say class can contain. Right now, this is also a class. Started with the class keyword. Class can contain methods and the variables. Class may contain methods and the variables. Then, when you create an object from the class, then that particular object inherits the variables and the methods from the class. Right, then we have already know about how to create a class, how to create an object. Likewise, then using a class, you could create any number of objects, and you know that each object has its own copy of instance variables. Right, and then we discussed last week what are the variables and what are the access modifiers we could use, and what are the methods, and how to pass the parameters, and what is the constructor, everything we have discussed. Right now, we're going to talk about encapsulation. Right now, encapsulation is, now if you can remember, um, let's say, now I'm going to create a class called student, new Java class called student. New Java class called student, and the student has int ID, string name, integer marks, and it has a method called up into getting. Right. Marks variable value. Right. Let's say now, right now in okay here this is our class student, and then from the Maven project 7, which has the main method, I'm going to create the student class object, and then I'm going to create student s equals new student. Right. Then I can assign the values. Right now, rather doing this, if you want, you can have the constructor for this. Therefore, you can generate it constructor. Right click, insert code, constructor. You can select the attributes and then select generate. Right. Now, once you generate it here, then here, if you want to create an object, you need to pass the values to the parameter variables declared, parameters declared. Let's say 101, window 45. Right. Now, using the object, now I can call a start print information. And thereafter, I can change by accessing the start name, I can change it to another. Start marks into 25. Likewise, I can change. Now, if I call the method print info, right now you can see I will be able to see the updated values. Now there's a problem. Why? Now based on the declared access modifiers, right? Now, since I can create the student as subject because both are in the same package, therefore, even though the class declared as student, public, therefore public class, student is a public class, therefore any class could access the student class, right? So then any class can create an object of the student class. And here these variables, instance variables declared as default, therefore only within the package level you could access. The print info method also default access, and the constructor is a public. So here these two are default, therefore only within the package we can access. Right now the Maven Project 7 class also in the same package, therefore it could access. Now the problem here is any class which has access to the student class using the by creating an object and then using the object name dot variable name, you can access the variable value. Therefore, anyone can change the variable values. Therefore, if you don't want anyone to change the variable value such a way, because right, the one anyone who created a method, who created an object from the student class now can change the values of these variables. Therefore, if you want to stop that, now what we can do is we can make these instance variables as private. Therefore, if you make it as a private variable, right now you know only within the class you can access. Right, only within the class you can access. Now, outsiders, except from the class, will not be able to change the variable values using variable name dot object name dot variable name. They cannot access because these variables have private access. Now only within the class you can access. Therefore, encapsulation means, right, by making sure all the data or the sensitive data is hidden from the outsiders. Therefore, outsiders will not be able to misuse the variable values because you have declared instance variables as private, so no one would be able to access. Only within the class can access. Now, even though let's say you do it, but you want to allow someone to change the name. If the name is different, only the name you want to allow them to change. Let's say you want to allow name to get changed. Then you could declare public method saying public. Right now, return type is void. Public return type is void, and then you can say set name. And then we can pass a name value here. Right now, we are passing a value to the method set name. Then what we're going to do here is, here we're going to assign, because inside the class we could access the variables, this dot name is equals to the local variable name. Right now, for now, I am declaring a method called void set name, no return, but I am declaring a method called set name. If you want to change the name, now you can't access it like this object name dot name. You can't do it because I have declared if you want to do this, you have to go through this. I'm allowing only to change the name, and I want to allow outsiders to read the variables values. I want to I want to allow outsiders to read the variable values. Therefore, I'm gonna return type integer, and then I'm gonna have get ID. Right. Now get ID. Here what I'm gonna do is I'm gonna return the ID. And I'm gonna return the name. Therefore, return type string. I'm gonna change it as get name. And no parameters required because I want to return the name. Then I can say return name. And also marks also I want to allow to read the marks only, not to change it. Therefore, I'm gonna public integer to get marks. And I'm going to return the marks variable value. Now, if you want to outsiders to access it, then if outsiders wants to change this one, then they have to go through the, right now they can't do it like this, then they have to call the method s dot set name, and then they have to pass the value. And if they will not be able to set the marks anyhow, because no public method declared for marks to set value, but they would be able to only to read the values. Therefore, if you want to access the variables values, then they could access by name is equals to s dot get name. Likewise, they would be able to access it. Right now, this is what you call as the encapsulation. See? Right now, if you run this, now you'll be able to access the name ID marks values, but you only able to update the name only, because we have declared only one set name method. Right now, even if you call the print info method, it would display according to the change value. Right now, you can see here rather than saying Jendo, it says another group marks 40. This is what you call as encapsulation. How? By making all the instance variables as private and declaring public get methods and the set methods. Right now, these you call as accessor methods or getters and setters. Now, these methods you call as getters and setters. Right now, If you want to declare this, I'll show you a shortcut. Right now, if you want to create like now, you just have to type this. Once you do right like this, what you have to do is, if you want the constructor, right click, select insert code, select the constructor, generate the constructor by select. And if you want to declare the getters and setters, right click, select insert code. If you want only the getter, select getters. If you want only the setters, select setters, set methods. If you want both getters and setters, select both getters and setters and select the attributes which you want, getters and setters. And then in order to make encapsulation, select encapsulate fields. Then automatically these fields become private and this will generate public getters and set methods, get methods and the set methods. Then using the get methods, you can retrieve the value. Using set method, you can update the value. That is how you can try out. You quickly try. Create a class called item and have a value called item name and the price. And then you create another class called test and with the main method and then declare the encapsulation and getters and setters to access. Quickly try out. Right. Right now, that is how you use the encapsulation. Right now, again, as a summary, what you do, you make all the instance variables private, therefore, no one would be able to access. And for the fields you want to allow them to change, you declare the set methods like this. And those variables you want outsiders to read, you declare the get methods by declaring getters and setters. That is how you do the encapsulation. Right. And then some of you may heard about that data hiding and data abstraction beforehand. Like before the encapsulation, you may have heard about abstraction. Yes, abstraction means data hiding, abstracting data. What is abstraction? Abstraction means uh, a programmer hides all these variables and methods inside a class. Right now, therefore, now all the information about a method object is hidden or is put inside a class. Therefore, right now we for the maintainability and for the reusability right now to increase the efficiency. Now, when you create the student objects, how the student object can behave is defined in a class, and then these are declared inside the class. Therefore, the class you can say is a general representation of an object, or class is a general abstract representation of an object. Therefore, class specify what are the fields and what are the methods an object can have. Therefore, object. Now, this object, student object. Now, student object has the ID, name, marks. Now, this is what declared in the student class. Student object can call the get marks, call the get ID, call the get name, call the set name methods, because that is what are those are the methods declared in the student class. Therefore, class is a general abstract representation of an object Right. Right now, if you talk about let's say car class or item class, then attributes you want to have for that. Right now, for an example, if you want to declare car object, and if the car objects need to have car type, car model, and whatever the engine capacity like us, then you have to declare in the car class, right, with those instance variables. Therefore, you declare whatever the in order to describe each object, the attributes required are declared in the class. Therefore, class is an abstract representation of an object. Class is an abstract representation of an object. Right. Then we discuss about the encapsulation. Encapsulation is achieved by making all the instance variables private and declaring public getters and setters method or public accessor methods. Right. Right. Then right now let's go into abstract classes. Right now, abstraction is the process of hiding the data and showing only essential information to the user. Therefore, abstraction can be achieved via abstract classes or using interfaces. Right. Then abstract class. Right. Abstract keyword is a non-access modifier. Then you can use the abstract keyword, which is a non-access modifier that is used for classes and methods. Then if it's an abstract class, that means which is a restricted class which cannot be used to create objects. Right now, if I make this class as an abstract class, right now, if I have declared the student class as an abstract class, right now, here, let's say now I have declared the student class as an abstract class. Right now, if I try to create the student object now, let's run it and see what's going to happen. Right now, you will see you will get an error saying student is abstract, therefore cannot be instantiated. Therefore, if you create a class as an abstract, then abstract classes cannot be instantiated. That means abstract classes cannot be used to create objects. Therefore, abstract is a non-access modifier which make the class restrict to or which restrict the class not to create objects from the class. Therefore, no one can create an object from the abstract class and use it to access the abstract class. Therefore, abstract class. Right. If you create an abstract method, let's say hello. We have a public void say hello. Right now, this method, right now, this is an abstract class. This is a normal method. If it is an abstract method, then abstract methods can have only inside the abstract classes. Abstract methods can only be declared in abstract classes. Right now, I don't need these getters and setters at the moment because I'm not doing encapsulation now. Right now, let me show you. Now, this is a class now which I'm going to declare an abstract method. Therefore, abstract method does not have a body part. Abstract method does not have body part. Therefore, now here, if you make it as an abstract, public abstract void say hello. Right now, here you can just put a semicolon here. Now, no need of the body statements for the abstract class. Right now, abstract classes can only have abstract class. Abstract methods can only found in abstract methods. Right now, what's wrong with this public abstract pro? Void cell right now. Abstract methods can only be declared in abstract classes. Abstract methods can only found in abstract classes. If you do not make it as an abstract, now you will get an error saying class is not abstract. Therefore, you cannot have abstract methods. Therefore, if you want to have the abstract methods, then the class has to declare it as an abstract class. Now, if it is abstract class, cannot create object from the abstract class. Therefore, what you can do is, if you want to access the if you want to access the abstract class right now, you need to create, let's say, let me create another class called test. And I'm going to make the test class as a subclass of extends the student class. Now, if this extends the student class, right now, this becomes a subclass of the student class. Now, so either this test class has to override the method here. What is the method? Say hello method has to implement the say hello method. Otherwise, you have to declare this as an abstract class. Therefore, either because now test class inherited the say hello method, which is an abstract method declared in the superclass, which is a abstract class. Therefore, if you want to use it, if you want to either you have to make it as a abstract class or you will have to implement the method say hello. Right now, then you have to implement the method say hello. Right now, you can even you don't have to use the auto. You can just you don't have to do it like this. You can implement the say hello method. Let's say let me remove it. Void say hello. Right, then I can say student says hello. A test says hello. Right. it can set SSL. Right now, here we can't create the student objects, but we can create the test objects. Test equals new test. Then I can say t dot say hello. Right now, this is how you deal with the abstract methods. Right now, abstract classes and abstract methods by using abstract keyword. Right now, abstraction is the process of hiding the certain details and showing only the essential information to the user. This can be achieved by using the abstract keyword, and methods and classes can be declared as abstract. Therefore, if it is an abstract class, you cannot create objects from the abstract class. And if it is an abstract method, can only be used in abstract classes, and abstract methods does not have the body statement. Abstract method does not have a body statement, and um, therefore the body for the abstract method is provided in the subclass. Now this is where this is a subclass, and in the subclass the body is provided to the abstract method. Right now, this is how you can deal with the abstract classes. Now here we have just declared the created an object from the test class, and we have done it. And for you to see this, right now I will show you like this. Okay, quickly try this one as well. Quickly. That is how you do the abstraction. Then we can go to the inheritance. Now, then we have to talk about the inheritance. Right now, inheritance, like now, here also we have what we have done was we have made the student class as a super class and the test class as the child class. Now, what happens right now? Let me remove the abstract class declaration here and let's say the student class has oh yes. We have right now we have name and integer ID. And let me declare the constructor for this. Alright. Now then let me have method also say hello. Alright, now here this is the student class. Right now the test class become a subclass of the student class. Now once the test class becomes a subclass of the student class, now since the construct is declared in the student class, now here this will ask you to generate the constructor for you. Right now uh, we can have the construct. Right, now once you have the constructor, now that's it. We have the constructor declared. Right now, if you create an object from the test class, if you create an object from the test class, right now we have the test class object which you need to pass the name and the ID. Let's say 101. And then if you want to print the method, say hello. And if you want to print the name, right now you can see here, right now we have not declared any variable here, right? But we have not declared any variable here. And if you run this, now it should the test class dot say hello method. I'm going to call test class dot say hello method. Now there is no method called say hello declared in the test class. See, but the test class inherited the say hello method from the student class, because in the student class we have the say hello method. Student class we have the say hello method. So now the test class inherits all the attributes available from the superclass. Therefore, in Java, it is possible to inherit attributes and methods from one class to another by going through the inheritance. Right now, inheritance make one class as a superclass and the other class as a subclass, parent class and the child class likewise. Then here the parent class is the student class, and then this is the test class is the subclass. How you make the test class as a subclass or the child class by using the keyword extends. By using the keyword extends and providing the superclass name, this become a subclass. Right. And then this test class now inherits all the attributes and all the methods declared in the student class. Right. Now, if you don't have the constructor there, if you don't have the constructor there, right, you don't have to declare the constructor even. Right. Now, let's say right now, you can see test class, we have not created anything in the test class, but if you create an object from the test class and you can call the say hello method, and also you can print the name. You can read the value of the name variable and the ID variable because there are values assigned for these name variable and ID variable, and it has a method called say hello. Where? Because you can see there's nothing declared. But how you get it? By the superclass. Because superclass has those, therefore, child class inherits automatically. Child class inherits automatically. Okay, quickly try out. Right now, you may have some other cases. Let's say now we have the constructor here. Let's have the constructor here. Right. So, huh, because of this. Eh, yes, because we have assigned the values there. Right now, right now for this, right now in this case, now once you become a subclass here, you will get an error because the constructor is missing. Right, therefore, let's generate the constructor as well. Let's say here we need to have the marks. Right now, here, if you want to have the marks, if you want to have the marks variable here, then at the constructor also, you can include the marks, integer marks. And here, after that, you can say this dot marks is equals to marks. Likewise, now if you want to create right now, here you have added an extra attribute in the test class. You can have extra method as well. Uh, say get print me get info. Right now, I have declared another method called get info. Now here, if you want to create the test object now, we need to pass the name. Here you need to pass the ID and the marks. And then still you have inherit the hello method, and also you can call the t dot get info method as well. If you call the get info method now, now this would display name, whatever the name you have passed Jane Doe, and the marks you have passed here 45. Now it would say name Jane Doe and marks 46. And the student says hello also would display because from the student class we inherited the student says hello. Right. Okay, quickly try out this. Right. Then, right now that is how you work with the inheritance, right? Then the polymorphism. All right, the inheritance, and then we have discussed about. Okay, let's see. Um, right now, let's see. Here we have. Okay, now we have default access, right? We have default access. That's right. Within the package, we could do this, right? Right now, let me show you. Last week also, I might have showed you this. But anyway, let's create another package called code, and I'm gonna create the test into a code. Right now, the test class is inside the code package. Right. Then right now you can see here when it tries to name variable, now we have an issue because we are trying to read the name variable inherited value, but now you can see now because this is declared, if this declared as a public, then no worry, you would be able to access it because it is declared as public, because anyone could access. Right now, if the student class and the test class are in two different places, and if this is not declared as public, now you can see here, even though it's inherited, you will not be able to access. Now, this is where the in protected keyword comes in. Right now, if you can remember last week, we discussed about the protected. Right, if it is protected, right now, if it is protected, right, within the package, fine. But outside the package, but if it is a subclass, through package level plus through inheritance. Now, if since this is declared as protected, that means package level anyone could access. But if it is outside the package, only through the inheritance you could access. Outside the package, only through the inheritance you could access. Only through the inheritance you could access because of the protected keyword. Only through the inheritance you could access. Right now, that is what the protected keyword does. Therefore, remember that as a protected keyword. Therefore, when you use the protected, that means protected keyword allows you to use through the package level access plus through inheritance. Right now, this inheritance can be used rather reusing the same code again and again. We could use the inheritance quickly. Right now, what I want you to do is quickly, I want you to quickly create, I'll give you 10 minutes max. Right now, quickly create a class called account. Account class should have owner string owner string, and then we need to have the balance float, uh, float balance, and then owner account ID, ACC ID, account number, right? Account number integer, uh, owner string, balance float, account ID, and we have to have void method called check balance, which is void, and deposit, which has the amount, void, and withdraw. Withdraw and amount and which okay, oh void. And then after that, I want you to create a subclass called savings. Savings account, you need to have another one called interest rate, int rate, integer, okay, float, integer int rate, and cal interest. And there you should have one attribute additionally for this one. And this should be a subclass of the say account class, and then we need to have the RFD uh, fixed deposit, FD, FD, um, uh, fixed deposits. There you need to have the interest rate, and which is a subclass of the savings as well. Additionally, I need you to have the term. The term. Right, now quickly try out this Right. Okay, let's do this quickly. Count string, string, we're going to balance account. Let's say I have a new package called General. Right. There, I'm going to create the savings class, account class, no? Account class, and what are the fields? We said account owner, string owner, integer account number, float, balance. Now, I should think of like sometimes the classes may declare inside outside the package, maybe. Therefore, it's concerned about the access levels as well. Therefore, protected. Right. Then we need to have the constructor. Then let's get the constructor. Right. Now I had some methods declared. What were the methods? Check balance. Let's make it as public. Void current balance. Balance is right. Deposit float amount. Um, we can check whether if the amount is greater than zero. If the amount is greater than zero, then only we should consider this. Then balance plus equals amount, and then we can display deposited. Right then, right now for the withdraw, and if the amount is greater than or equals to the balance, then only amount is less than then only you would be able to do that. Balance minus equals amount and withdrawing Withdrawing. And otherwise, this is less insufficient. Insufficient balance and afterwards you can call the anyway you can call the check balance method. Every time after depositing or withdrawing, you can display the current balance. Right. Then this is about the account class. Right. Now let's create another package called savings. And there I'm going to create another class. Right. Now we can have a savings class, which becomes a subclass of the account class. Right now, the constructor is missing. Therefore, let's beforehand I need to declare the variables I set interest rate. No, floating rate, and then we can add the constructor. You can see the interest rate. Let's pass at the end. All right, now we have the interest rate, and then we can have a method called calculate interest. Right now, interest calculation, we can have what interest rate will be balance multiplied by interest rate for monthly, let's say monthly interest rate. Mm, interest rate divided by right, it's up to you to come up with the calculations. Interest rate divided by 100 If you want, you can divide this by 12 as well. If you want to get the, what does it say? Float int int is a variable. Again, you can call the method check balance. Right. Right now, this is the savings account. Right. And then, right now, let's say here I'm going to have the fixed deposit as well. Fixed deposit. This become subclass of savings class, and then this has a term declared, and now we can have the constructor. Like previously, we'll have the term at the end. Right now here, let's override the method. Now, right now I'm going to show you how to override the method. To calculate interest, not to calculate the interest like this. Here, to calculate the interest by balance. Balance multiplied by interest rate divided by 100 into term. And I'm going to print and say interest at maturity is 10. Right, likewise, I'm going to have. Right now, you can see here the same calculate interest method, which is available in the savings class I have used, not to do the same task like this, right? But to show the interest at maturity. I'm going to say FD term is plus years. Right now, it's a matter of Right, now try out this quickly by creating another class called driver and then create savings account and FD class, fixed deposit, and then see how the objects behave. Right now, if you create another class called driver, let's say I'm going to create new Java class called driver. Now in the driver class here, I need to have the main method. Right now, I'm going to create a savings account class. Then I can get as the check balance as dot deposit another 10,000 as dot withdraw the 5,000 and as dot interest calculation and interest. Okay, this is outside the method, and therefore this has to be a public method. Right now, afterwards, I'm going to create another one called from the FD fixed deposit, FD equals new. S dot, let's say check balance, and S dot calculate interest, and yes, that's it. Now, if you run this, right now it says current balance is 10,000, deposited 10,000, then deposit amount must be positive. What's wrong with this? The deposit. Let's see the account class. If the amount is greater than zero, amount is 10,000, 10,000 greater than zero. Then this has to be in the else, no? Right. Here also the same, no? We have forgotten the else part. Only one line, therefore I'm not going to use the brackets here. Then immediate line afterwards will take an as its body. It will show you that 10,000, deposit 10,000, current balance 20,000, withdraw 5,000, current balance 15,000, interest 10% of 15,000 is 1,500, then current balance is 16,500. Right. And that's it. And here, what you call, no, here it's not tested. This has to be FD dot check balance. FD dot check balance and FD dot calculate interest. Here that should display FD account, current balance is 20,000. When you check the balance, because you are putting 20,000 and then term 5 years interest at maturity, and then 10% of okay, interest rate is 20,000, 20%, then that into 5 years. The way you calculate, you get 20,000. Right now, this is how you work with the inheritance. Right now, you can say this account class is the super class, savings class is the subclass, and again for the fixed deposit class, savings class is the super class. That's how you work with the uh, inheritance. Now the polymorphism. Polymorphism is here, right? You can see the same method act differently. Right now here, when you call, now here you call the calculate interest in both savings account and the FD savings account and the FD class, savings class and the FD class. Right now, when you call the savings class, it shows like interest and it will add into the interest and it will check the balance. This is how it will display. But when you call the FD class interest, it will display differently. Therefore, the polymorphism means taking many forms. Now you can see the same method, calculate interest, acting differently in different classes because for the same command, calculate interest, method acts differently in different classes. Now, that is what you call as polymorphism. Polymorphism means many forms. That means this occurs when we have many classes which are related to each other by inheritance. A method that each class can do different things. Now, that is done by overloading the methods. Sorry, not overloading. Here we have done overriding the methods right now because we haven't changed the parameters. So here this is done by changing the method behavior. That is what you call as overriding. Therefore, here calculate interest at the savings class, calculate the interest, but in the FD class, fixed deposit class, it shows you the term and it will show you the interest at the maturity. Now that is what you call as polymorphic behavior. Polymorphic behavior means having different behaviors. Right now, for an example, uh, you can call, for an example here, right, if you have, right, let's say speak method, and then if you have different classes like objects, let's say human, birds, dogs, cats, likewise, then when you call the method speak, then every object will respond differently. Or if you have a class called shape, and if the shape class has method called draw, and then if you have objects like, if you have classes like subclasses like square, circle, and rectangle, triangle, likewise, and if you call the method draw, then every object from each class will draw different shapes. Like one will draw the square, one will draw the rectangle, one will draw a circle, likewise. Then polymorphism means having many forms, right? This happens when you have multiple classes connected with inheritance. Now, in this example, we have calculate interest in the savings class as well as the fixed deposit class. And then when you call the calculate interest method, and it acts totally differently uh, in savings class and the fixed deposit class. Now, this is what you call as the polymorphic behavior. Right now, here what you have done is we have overridden the method in the method, calculate interest method, we have overridden. Right now, we have to talk about overriding and overloading. Overriding and overloading a method. Any questions up to now you can ask, and also I'll give you a few minutes for you to try it quickly. I think account class we have already done it now. You quickly do it. Right. Now, then we'll go into method overloading and method overriding. Right. And that, right, let's start with the method overloading. So right. Here, let's say we have a class called mm, okay, student item class, okay, calculator class. Right. Right. Now, in this class cal, let's say I have method called void add. There I'm gonna say is out no values to add. And now you can method overloading means right now reusing the same method name. Method overloading means reusing the same method name by changing the parameters. Now, by changing the parameters. Then overloading means reusing the same method name by changing the parameters, right? Now, method overloading means reusing the same method name by uh, changing the parameters. Or you can say by changing the parameters is here right now. We have to change the parameters. Right, and then changing the types, or you have to anyway change the parameters. Right now, that means it will allow you to, overloading will allow you to reuse the same method name with different parameters. Right, or with optionally different return types as well. For an example, we have integer x. You can say, right, one value. And if you want, you can have integer x and integer y. There you can return the value. Okay, x plus y. But and if you want, you can have here three integer values: integer x, y. Then here you can say x plus y plus z. Or here you can have one integer. Here you can have float x, integer y, integer z. Then here, likewise, you can have. Now we are passing a float value and two integers. And then here you can pass float x. So let's say integer x and then here float y. Right. Now likewise you can have you can see here, and now the same method name has been reused. Right now same method name has been reused, but same method name has been reused with different parameter sets. Therefore, method overloading means multiple methods with the same name with different parameters. Multiple methods with the same method name with different parameters is what you call as method overloading. Right now, let's create another class called, okay, driver class we have here already. Then let's create the cal class. Cal equals new cal. Right. And also we'll have the method name. Right. Right now, here if you pass, right now C dot, and if you pass only, let's say 10. Let me pass. If you pass C dot and no values at all, and one integer value of let's say 10.5, float value, just only the float value. Let's say we pass the value something 10 non-integer, two integers, 10, 20, 30, 10.5f, 20, 30, float value 10, 20.5f, 30, and 10.25. You can't pass now, right? Right. Now you can run this and see how the which method will get executed each time. When you call, okay, so package save does not exist. Uh, right. Now when you call the first one, add method, it says no values that. When you pass only just one value, it says one value. When you pass 10 and 20, it says 30. When you pass 10, 20, 30, it triggers integer 1. That means it triggers this one. And that will give you 60. And then when you pass 10.5, 20, 30, then that triggers float int. That means this method. And then that gives you 60.5. And then you pass int float int, then that means 10, 20.5, 30, int float int. That also gives you 60.5. Right now, this is how you could work with the overloading methods. Now, what you have to remember is when you're using overloading, method overloading, you have to change the parameters. It is a must to change the parameters, either number of parameters or the type of the parameters. Number of parameters or the type of the parameters must be changed. Therefore, remember, multiple methods can have the same method name as long as the number of parameters or the type of parameters are different. Now, that is how you use method overloading. Right, now we can try out this quickly. Right now, I want you to write a method called calculate area, right? Write a method called get area or calculate area, something, and then write a method called get area, calculate area. I want you to calculate the area of a square. Um, how you get the area of a square? If it is a square, the area is given by x into x. If it is a rectangle, uh, re- how to get the area of a rectangle? Okay, x into y, length into width. And then if it is a circle, all right, you need to have the phi value as well. Okay, phi value we can say 3.14 into r into r. Likewise. Right now, quickly create a class called shape. Create a class called shape. Inside the shape class, okay, shape class, have a method called area, calculate area, and then class shape, have a method called area, and then have these methods. That means same, you need to overload the calculate area method to calculate area for the those values. So the pi value, as you already know the math, then you can have math dot pi. Right. Quickly try out that. Have a method called calculate area. And I want you to overload the method to do these calculations. You quickly do it. Right now, I hope you have done this. Right now, if you want to do this, you just need to add another class called what I said, a shape, right? Class called shape, and then you need to come up with area. Let's say public int area. Mm, if you want to get rectangle square side, then you can say return side into side. And if you want to calculate the area of a rectangle, then we have to get the length and the width. Then we're gonna multiply the length into width. Right. And if you want to calculate the length of a circle, you need to get the radius. Okay, teacher radius. Then we can have math dot y value into r into r. And this other source. Right, right. Same variable type used now. We'll have it as float. Right. Then return value would be double because method pi would give you a decimal value. Right. And then here in the driver class, if you want, you have to create a shape class object shape class C equals new shape. And then you can say area of area of uh, rectangle. Rectangle is you can call by x dot area by passing, let's say 5. Then you can call area of rectangle square. This is a square. No? Square. Rectangle is you need to pass 5 and 6. Area of a circle is, let's say, size is okay 4.5 f. Then that would display the area accordingly. Right now, because you can see the same method name I have used, the return types are different and the number of parameters are different, and then it calculates accordingly. Right. Then we can talk about the overriding overriding methods. And when it comes to overriding, inheritance must be there. That means is a relationship should be there. Right now, let's say we have a class shape has the area. Okay, okay, we'll have another set of uh, examples. How? Mm, right, then we can have right, then we can have like class co-location. Let's say shape. Shape has calculate area. Right now, let's say we'll have in the shape class we have method called return type is void, and let's say area. Here, let's say gonna print area of the shape. Right now, if you create another class, now this is the shape class, right? Now, if you create another class which become let's say rectangle, then rectangle. Now, rectangle class, when the rectangle class becomes a subclass of the shape class, now the area method is inherited already. Right now, here, let's say if we have the area method here, then we can define if it's a rectangle, rectangle area of a rectangle, area of a rectangle calculated by calculated by length into width. Right. Likewise, now this is what I want to display if I call the rectangle class. And if you want, this is how you can override the behavior of the area method. Now, area method, right now you can see when you create s dot area, that is a shape class, and when you call the rectangle, r equals new rectangle, and if you call r dot area, now you can see a rectangle dot area method would display area of a rectangle calculated by length into width, because now this is what you change the behavior of the area method. Right now the area method is inherited from the superclass. Area method declared in the superclass. Therefore, this is inherited to the rectangle class. Therefore, here you can see that you can add a override annotation. Here you can see you have changed the behavior. You have overridden the method area to change according to the rectangle class. Right, in the shape class, you can see here um, in the method area, if you move the mouse, you will see it's overridden because area method in the shape class has been overridden in the subclass and change the way it works. Right now, shape dot area will say area of a shape. The rectangle dot area will say uh, area of a rectangle calculated by length into width. The same thing what we did in the uh, previous account class, fixed deposit and the savings class when calculating the interest, the same thing we did. Right now, overriding methods, you could use the same method signature, and that has to have the inheritance. Only inherited methods can be overridden. Therefore, only inherited methods can be overridden, and then you could add this override annotation, that is optional. which allows you to identify that method has been um, overridden or not. Right now, what I want you to do is again have a shape class, have a method called draw, and then there display drawing the shape, and then have rectangle class. Override the draw method to display drawing the rectangle. Have a circle class, and then override the draw method to say drawing a circle. Likewise, have the different shapes, and then override the methods. Okay, try out quickly. Right now, if you create the class called shape, here we have the shape class. Let's say we have a draw method, public void draw. Then here you can say drawing a shape, and the rectangle class would say you can right click and insert code, get the override method, and you can get the draw method as well. Here you could say, and also even if you want to call the superclass, what is a super class? That means parent class method does. You can call by super dot area. Right now you can call the superclass one also. Here you can call the superclass one as well. Right now here then what the superclass does, and then here you can call this method behavior as well. Here I'm gonna say drawing drawing a rectangle. Right now you can see here after draw, right, you can have multiple methods, multiple classes, and you can have different behaviors for each class by overriding the method. Then you are overriding. Now you can say it shows what the superclass does because I'm calling superclass dot area method, then area of a shape, and then area of a rectangle calculated by length into it. Here I'm calling the superclass draw method, it says drawing a shape, and then it shows drawing a rectangle. Right now, therefore remember when it comes to overriding and overloading, when it comes to overloading, you need to remember that, right, arguments or the parameters must change in overloaded methods. Type of the parameters or the number of parameters has to be changed in overloaded methods. In overriding methods, you don't have to change any parameters. You can, if it is a relationship, that means if it is a subclass, can change the behavior of the method which is declared in the superclass. Therefore, this is overriding. This is what you call as overriding. And the same thing we did in the account class at the beginning, overriding, and then overloading means by changing, using the same method name by um, having different number of arguments, parameters, or different types of parameters. Now that's how you overload and override. Okay. Try out this as well, and then I will give you one exercise for you to try out. Um, right, any questions up to now, please ask till I figure out the question. Right now, you can come up with a class called employee and method called calculate salary. And you have different type of employees. Let's say full-time employee, part-time employee, temporary employee, likewise. And then full-time employee salaries are calculated by um, that means basic salary into a basic salary plus allowance. That is how full-time employees salary is calculated. Part-time employees salary is calculated by how part-time employees salaries calculated by hourly rate into number of hours, and temporary employees salary is calculated by number of days into daily rate, right? Uh, then create a class called yes, right now you can have right, okay, then this is right, you need to have employee class. I don't know, you need to have what are the attributes you want to have. Then you need to have full-time employee and part-time employee, full-time employee, part-time employee, and temporary employee. Part-time employee and then temporary employee. And the salary is calculated for the full-time employee by monthly salary plus allowance. And part-time employees are like number of hours plus hourly rate. Right, and then temporary employees, number of days, and daily number of days into daily rate. And now what you can use is in employee class, you can have a method called cal salary, calculate salary, right? And you can have overloaded methods, overloaded methods to overloaded methods to annual, hourly, or monthly, or daily salary, right? And then that's what you need to have there. And you need to have subclasses. And all right, now plus monthly salary plus allowance, and then add yeah, this is how the salary calculation happens, plus add the bonus at 10% bonus. Right, part-time employees number of hours into hourly rate, and contract the temporary employees number of days into daily rate. Right now, then you can have customized methods for right now here calculate salary has overloaded methods. So yeah, there are about 2 or 3 versions. Then in each subclass you can customize accordingly in order to uh, have the to calculate the salary accordingly. Then try out this. You can have your own attributes for the employee name, ID, type. Likewise, you can have any values, and then you can try out how to do this. Okay, any questions you can ask? Other than that, I'm done for today. And the next day, we're going to start with the collections framework. Any questions, please ask. Otherwise, I'm done. Thank you.